we're gonna finish climate right now. Okay? Extreme weather, one of the craziest things. We experience it here. It's the highlight of climate for me. I like talking about big, crazy things that happen naturally, like volcanoes and earthquakes and tsunamis. This one would be the climate related. So this is important because you're gonna have an assignment due on extreme weather, and it will be your chance to kind of get into some of the events that have happened in world history here in Canada and somewhere else. So don't worry about it right now, but this might be something you want to stop back on. I have a lot of videos in this slideshow that I will not be showing you while I do the video, but feel free to watch them on your own time. Some of them are pretty funny, especially the one where the guy gets hit twice by lightning. So I just don't have the time to tell you. But some things I'll show you while I do this, like we would in class, but I'm talking to an empty room right now, which kind of seems weird, but I'm just visualizing all of you here with me. Okay, extreme weather. We're gonna get into things like, I start out with simple rain because it is the same principle. We need moisture and we need a difference. We need fronts. Okay, the bigger the front, the worse the bang. All right, so tornadoes, blizzards, hurricanes, hailstorms, floods, those things. And a lot of them that are on here, we experience here in Manitoba and in Canada. Okay, so I'm gonna go quickly through this. Remember how basic rain happens. We need moisture. We need moisture to rise, okay? But when we talk about fronts happening, warm versus cold, warm goes up, cold stays down. Now what if this is really cold and really dry, and this is really warm and really moist? The more different these things are, and the faster this happens, the crazier the storm will be, okay? It's generally what it is. And pay attention to where a lot of the storms come from, specifically thunderstorms and stuff. We watch them drift in from the west as the prevailing breezes blow them through. So I'm going to skip over basic rain, but it is kind of the start of how a lot of these things happen. What happens to create, like how do we create lightning? What is responsible for lightning? Someone told me when I was a kid, and I was a very gullible kid, that the lightning came from the rings of Saturn. I soon, well, maybe in my late teens, I figured out that that wasn't the case. And they actually come from clouds. Yeah, okay. Someone actually told me before that wind was caused by the trees because they were like big fans. Yeah. Just a couple of years ago, I figured out that it was pressure, okay? But either way, we need I realize this is hard to see some of this stuff, but this is what causes lightning. We need a different charge, just like a battery. You don't put the red on the black and the black on the red, okay? Bad things will happen. So when there's enough charge, that's when electricity or a big spark would occur. I'm looking for that word here to launch out. There has to be something that meets it halfway, which is one of the videos that I would recommend watching. It's kind of a boring video, but it really goes into explaining how these things happen. Now remember, there's a common little thing here with our lightning storms. We get a lot of them. You see lightning, and then you count the seconds to when you hear the thunder, because the thunder is the sound that the lightning made. But light and sound travel at different speeds, right? So the closer you are, the smaller that gap is going to be. I've been in lightning storms where it's like they've hit my building before, and it sounds like a bomb's going off. Okay, so I needed to get a new pair of pants and figure out how to fix my computer that was plugged into the wall. But either way, you know, we get a lot of this. So every year, lightning kills a lot of people worldwide, right? Recognize this spot? If you ever have a chance, when we are allowed out in public and able to go and socially be with people again, That is on the Provencher Bridge. I don't know the name of the bridge, but there used to be a Salisbury House there. Good job, Winnipeg. But it's the $1 million washroom. If you ever have a chance to go there, make sure you use the can, because it costs $1 million to plumb in on a bridge. You're on a bridge, restaurants need to have washrooms. You can't just dump things in the river. Who would do that, right? Okay? So watch. Both of these videos are good. One is more sciencey, the other one is a guy walking and he gets hit by lightning twice. He lives. Okay? So the dry line is, again, think of fronts. You have cold meeting warm, and this is down in the States. This is Oklahoma, Tulsa, Oklahoma City, and this dry line here, if you take a good look at it, these are just massive clouds that are billowing and gross and look dangerous and weird. We're in Tornado Alley here, where here's the way it works. Thunderstorm warning, okay, potential of hail, which has the same potential to produce a tornado, okay? So generally, if you can actually see it in the sky, hail clouds look a little bit greenish almost. It's eerie, okay? There's a video on dry line formation that you can watch or whatever, but keep in mind that's, if I back it up here, this would be where the condensation is happening, right? Cool air probably coming off the mountains and continental, meeting with Gulf warm, moist air that is pushing that moisture up and creating these massive clouds that will produce, like this is Tornado Alley in the States, where they experience more tornadoes than anywhere on the planet, right? Hail. So I have a picture here. I'm just gonna flip the video around here so you can see. Hang on, if this cart wants to actually come with me. Okay, so I drew a big cloud. Okay, now we have hail here almost yearly. Okay, but the story behind kale, it's a vegetable. It's good, healthy stuff. Hail is really, really cool how it works. Because if you ever see a hailstone, don't go out in a hailstorm. I don't recommend it, or at least put a bike helmet on or something, okay? If you look at it, it looks like it's an onion, okay? There's layers to it. And that's an important thing, because the bigger the stone, the more layers have been added. And how do we get these layers? If you understand anything about gravity, if I were to drop this thing, it would fall on the floor. Okay, what are clouds made of? Wind, moisture, and dust. Or sorry, not wind. Moisture and dust particles, that's it. It's condensation in the air, okay? So how do these things keep water droplets, and more importantly, ice stones the size of grapefruits in certain circumstances? That's a lot of power involved. So I'm going to draw you a quick picture that goes along with all of this, and then someone else, there's a video linked in to show you exactly what I'm going to do. You need a very big cloud, height-wise, vertically, okay, to have that difference in altitude, as I said. So you have, generally, when a water, types of rain and stuff, the difference in terms of snowflakes that are huge versus tiny little ones is the strength of the cloud, okay, and the amount of moisture in it. So hailstones would react in the same way. So what you need is moisture, okay? So you have a little rain droplet that's ready to fall, but then what's called updraft, okay, pulls that rain droplet to the higher part of the cloud where there is kind of a freezing line, okay, where things freeze, altitude, make sure we have a big, tall cloud. So now this water droplet gets frozen and another layer. It falls, and then that updraft takes it back and adds another layer. And it falls, and depending on how many times it goes through this depends on how big the stone will be, right? So the bigger the stone, the more powerful to updraft, and that updraft is the same thing that's responsible for things like tornadoes, right? So if you get hail, maybe find a ditch, okay? So there's the same thing here. You can't see it, so I drew you one while I explained it. But here's a video on in terms of how how you'd see it. I'm just going to straighten us out here again. Okay, there we are. Business. So we're very used to hailstones. These things are not long lasting. They take, a 30-second hailstorm can wipe out crops, can break windows, can ruin cars, and cost millions and millions of dollars in insurance. So it's important that here in Winnipeg and Manitoba, like, you could be growing and put millions of dollars into your crops, and 30 seconds is enough to break your fields and food not produced, right? This is during the day, okay? Good time to go for a Slurpee. That would kill you, right? Okay? You gotta watch this video. So I put some notes in here because usually I would pause the video and say, okay, count how many times this guy says, "Oh my God," and count how many times he said, "I've never seen anything like this before." It's about 4 minutes, but the progression is crazy. Whoa, been talking too much today. Tornadoes. Getting worse as we go. Rain to hail, which are thunderstorms to lightning, to hail, to now tornadoes, where you need heat to rise super quick and mix with cold air. Excuse me. One of the things that is incredibly important is this. Okay, the pressure decrease. And I've sat on my deck before and watched some nasty clouds come my way, and just like, I don't know if that's good. It's just a black wall of death coming. And what happens is I stood out there and like, I should probably go inside and gather the kids and find a ditch, or, it just got all of a sudden, I sat there and I could almost feel it, the pressure decrease. And I was like, oh, that's weird. And it just got still. No wind, nothing, but this thing kept coming. You could see lightning. It's dark, meaning there's a lot of rain and stuff. And I kept sitting there, and all of a sudden, as it kept getting closer, the trees starting to go like this. So I went inside. Sure enough, hail fell. I was like, okay, kids, let's go downstairs at least. Thunder, lightning, like watching the trees do this in my yard. And then it passed. I went out, it was like, whew. And the next day, I live in LaSalle, and in St. Norbert, between LaSalle and St. Norbert, there was a tornado. So, I mean, it's the same thing, where that super quick drop in pressure was enough to, like, almost drag down this crazy thing. Super powerful, and we have them all the time here. So we need a massive cloud vertically as well to get that temperature difference. Okay? Now remember the dry line, the biggest car, like if you're gonna have a car crash, you're gonna experience the biggest oomph where they meet, right? This is a perfect description of a dry line where the nasty part is right where these fronts are meeting, right? The most unlucky house ever at this time. And again, dry line, you can see it's sunny on one side and nasty on the other, where these things are meeting, right? These are some videos on tornadoes. The one about Dallas is crazy, where semi-trucks are being thrown hundreds of meters. Crazy. And the Ottawa tornado recently, there were 16 tornadoes in 2 days in Ottawa a couple of years ago, I think, maybe last year even. Okay? Blizzards, we get them here all the time. Slide is like a blizzard. To get a blizzard in Winnipeg, we gotta have moisture, okay? And it's gotta be a little bit cold. Thanks, Tips, okay? Which would lead to things like floods, okay? But just on the blizzard thing, hang on a second here. Yeah, I got time. Just checking the time here. I used to live out in the country, and traveling in blizzards, not a great idea. Okay, I still live out in the country now, sort of, a lot closer. But there was one time when I was exactly your age, grade 10, that I went to this school and needed to get home to grab some. I think we were going on a ski trip the next day or something, and we usually had a rule where if we drive to this point and it's nasty, turn back because the next little section is worse. So both my dad and I had to get through this, and so there's this one thing, like, we were driving so slow and I wasn't driving yet, so I was sitting in the passenger seat and my dad's next to me, and he's like, son, your job is to hit me if you see any lights, like red or yellow, okay? Because his job, he opened the door while he drove and drove like this, looking at the tar line in the highway so that he knew that he was on the road. Super safe. So I'm here like this, trying to see lights, and I can't basically see anything, and he's driving with the door open during a blizzard to see the tar line. But then our house was off the highway, about 2 miles off the highway on a gravel road, so he's like, son, put my jacket on, here's some extra mitts, get outside and run in front of the car. That's a great idea. So basically, I'm bundled up like the Michelin Man, and I'm trying to run. You can't see anything. Like, I literally could not see my hand in front of my face, but I could feel the road under me. And there were a couple times where I ran into the ditch and was like, oh, don't follow me in here, because I had no idea where I was. So that was a super fun experience. Stay home, don't drive in blizzard. Floods, obviously, if you have more moisture, it's runoff, right? And I'm guessing Winnipeg might be in a little bit of trouble this spring just because of the way things worked in September, wettest September ever. Then things froze. Then snow piles up, and we just got some late snow as well. If it warms quickly, this could be a problem. That's exactly what happened in '97 as well. Okay, where this is Morris, Manitoba, a couple of lovebirds on a bench. Maybe they were even there before the flood. Here's our floodway. You can really see which side of the floodway you want to be on, right? And this was back in '97. Again, they built what's called the Brunkild Dike, and now it's permanent from St. Norbert all the way to Brunkild still. It goes right by my house in LaSalle. They wanted to prevent the Red River meeting the Assiniboine so that the floodway system would have been useless if it would have reached Winnipeg. Okay. Lastly, hurricane season usually from August to maybe November, but you need warm air. Those currents coming in, bringing warm air, and again, any type of disruption might be enough to cause a hurricane. So here's Hurricane Katrina in 2004. You can see this is Florida. So you can see how big these systems are, right? That's a hurricane coming to town. These massive walls of just. Those are the roofs of houses in New Orleans, or better yet, New Orleans. A lot of people died. Okay, no help either. So these are some good documentaries if you are willing to watch anymore. The one on Sandy was a hurricane that hit New York City and New Jersey. Really, really good. And you can see kind of the economic damage that they do as well. I believe that's it for climate. I will continue to post things, but I wanted to do all the videos at once so that you have enough to think about. Don't try watching these all at once. Make fun of me all you want. Okay, miss you guys. Hope you're doing well, and send me any emails, write questions. You can only go up from here.